Now I take the topic, the magnetic susceptibility. Here susceptibility means that up to what degree this given material can be magnetized. So this susceptibility represents the intensity that represents the degree of magnetization to the material. It represents the degree to which an unmagnetized material acquires the magnetization in external magnetizing field. Magnetizing field. So the intensity of magnetization, the intensity of magnetization is proportional to the applied magnetizing field. Magnetizing field. H. It means that this I is proportional to H, or this I is I upon H. This is equal to a constant, or this I upon H. This constant is called, denoted by the term xi. This is called xi. I upon H. This is equal to xi. Where xi is the susceptibility So it indicates that when we are having this I and H, I take on the y-axis and H on the x-axis, and just I have the line. This I is proportional to H. Then if suppose we are having the slope of this line, this angle suppose theta, then this will represent this the xi. So the slope of I versus H line represents the susceptibility. So we can have that the slope, this is denoted by tan theta, this is equal to I upon H, or this tan theta is equal to your xi. So we can have the value of this. If we know the value of theta, then we can find the value of xi, or theta equal to tan inverse xi. Now this susceptibility is unitless. Susceptibility is unitless. So it has no unit, and its dimensional formula that we can write it to be the N0, L0, T0, etc. So all the dimensions will be equal to 0. Now susceptibility now from here we can define to this susceptibility xi equal to I upon h. This is not used so much. I upon h. I upon h. So now if we have that is h equal to 1 ampere per meter, if h equal to 1 ampere per meter, then this xi is equal to I. We can define to this xi. So the magnetic susceptibility, it means the magnetic susceptibility is equal to the intensity of magnetization when material is placed in magnetizing field. In magnetizing field of 1 ampere per meter, of strength 1 ampere per meter. Strength 1 ampere per meter. So this is the definition of this I based on the definition of xi. Now this value of xi is different for different materials. Xi is greater than 0 for para and ferromagnetic material. Ferromagnetic material. And xi is less than 0 for diamagnetic material. Diamagnetic material. When this xi is equal greater than 0, it means that xi is positive. So xi equal to positive. This is for para and ferromagnetic material, and Xi equal to negative for diamagnetic material. So this Xi equal to positive and negative. This also represents the force of attraction or force of repulsion. If Xi is positive, it means that it represents the force of attraction, and when Xi is negative, then it represents the force of repulsion. It means that the material which are attracted by the applied magnetic field, then this Xi is positive. If they are repelled by the external magnetic field, then Xi is negative. So Xi equal to positive means attraction. That means this para and ferromagnetic material are attracted by the applied magnetic field. So para and ferromagnetic material are attracted by external field, and Xi equal to negative means repulsion. Xi equal to negative. Negative means repulsion. It means that the diamagnetic material are repelled by the external magnetic field. The diamagnetic material is repelled by external magnetic field. Magnetic field H. So we can have that if suppose Xi is given to be greater than 0, or it means that Xi is positive. So this is for the para and ferromagnetic material. When we are having Xi less than 0 means this is the negative. So in that case, this Xi will be negative, and this is for the diamagnetic material. This is why that the diamagnetic material are repelled by the external magnetic field. So now we can have the graph for these. Suppose I am taking to this one. This I take y-axis, this is now your x-axis. This is y dash, this is now your 0. Here I take this I, and I on this side is positive, and on this side it is negative. So this is like this. It is for Dimagnetic material for diamagnetic material. Because chi is negative means that this part must be negative 1. So here we have this H, the applied magnetizing field, and in the case of this para and ferro, this I take here x, this is now your y-axis, this is 0, this is I, and this is now h. Then we are having a straight line, I proportional to h. This is for paramagnetic. For paramagnetic. Paramagnetic material. And if I take I and this is now suppose x, this is now y, this I take now I 0, here is h, then I get the curve like this. Like this. This is for ferromagnetic material. Magnetic material. This is for ferromagnetic material. So thus when we are getting the straight line in the positive quadrants of I and H, then we are having this to be now positive one, and also this is in the form of the curve for the ferromagnetic, because the ferromagnetic material are strongly attracted by the external magnetic field. So this is about the magnetic susceptibility, and always remember that this magnetic susceptibility represents the degree of magnetization to which the material can be magnetized in the external field, or the material acquires the magnetization in the presence of external magnetizing field. So this is about the magnetic susceptibility. So thank you very much.